let's try to solve another Leetcode problem, 2847, smallest number with giving digit product. So for this problem, we are giving a positive integer n, and we need to return a string representing the smallest positive integer such that the product of its digit is equal to n. So if we cannot find such smallest positive integer, so we're gonna return a negative one, but it's gonna be a string. So let's just first use the first example to explain what is the meaning of the problem. Yeah, 105. So we have 3, 5, and 7 because 3 times 5 is 15 times 7 it is 105. Yeah, it is just those three numbers, and 3, 5, 7 gonna be the smallest number. And for the second example, because there's only one digit, 7, so we're going to return a string of 7. So for this example, 44, because it's going to have something like 4 times 11. So definitely we're going to, we're going to have the number 11. This means we cannot split 11 anymore. Yeah, because we need to get the smallest positive integer such that the product of each digit is equal to n, but for 11 it means 114. It is not equal to 44 because we cannot split 11 anymore. Yeah, so that means it is not possible. So let me just give you two examples. So if n equals to 27, so what do we have? We're gonna have some numbers. So for example, like 3 times 3 times 3. So it means we're going to have a string of 333, but it is not the smallest number. We need to have the smallest number. Yeah, and we're going to return a string. So what about 3 and 9? So for example, we're going to have 93. This is string because 3 times 9 is 27. And definitely this is smaller than 333. But as you can see, why not we just put 3 first? Make it 39. Because 39 is going to be smaller than 93. Can we find even a smaller number than 39? No, we cannot. Yeah, so this is the only numbers we can find. So the idea is a greedy idea. So we're going to use this number n to check all the possible cases, but we're going to check from the maximum digit to the smallest digit. So basically for this 27, we're going to check it from 9 to 2. We're going to first check 9. Oh, 9 is possible. So 27 divided by 9, it is 3. Now, this means we have a 9. What about 3? For this 3, definitely we're going to try the biggest number 9. It is not okay. And then we're going to continue to check. Oh, 3 is possible. Yeah, because 3 divided by 3 is 1. So now we have a 3. After we check it from the biggest number to the smallest digit, and we get this kind of string. But what for our return? We just need to reverse the string because after reverse, it's going to be 39 and in a string format. So this is the final return. So why I can think about this kind of idea? Because I did the similar problem a few days ago. Basically, the idea is similar because in Leetcode, especially for Leetcode, I'm not sure about our platform, but for Leetcode at least, there are going to be at least 2 or 3 similar problems. If you solve this problem, if you know how to do it, definitely there are going to be several similar problems use exactly the same pattern. So the pattern is the greedy idea with mathematics skills. Now we're going to try to solve it. So if n less than 10, so this means n is a one-digit number from 1 to 10. So if it is like that, as you can see, this n is going to be really big, 10 to the power of 18. So definitely we're going to use the greedy idea. So if n is less than 10, so we're going to return a string of n, right? Now we're going to prepare a nums string. So I'm going to use a list of the range from 2 to 10. This means 2 to 9, but I need to make a reverse because I want to check the biggest number first. Now I want to check this number n, while n not equal to 1. Why I set it to 1? Because according to my example, if I have 27, so for this number 27, I divided by 9, I got a 3, and then 3 divided by 3, I got a 1. So from here, while I get a 1, This means everything is okay. I get a 1. I need to break the while loop. I need to stop it because I'm pretty sure I can get the final result. It's going to be 9-3 and final result going to be 39. Yeah. So now we need to check from the maximum number to the smallest number. So let's say for v, this means it's going to be another number for v in nonce. I just need to have a check. So for n modular v equal to 0. Yeah, this means it is possible. So for example, for 27 modular 9, it is possible because 27 modular 9 it is 0, so we can update the number n. So this n gonna be divided by v. Yeah, but here it's not only once. If that is possible, we're gonna check many times. Yeah, so while n modular v equal to 0, we're gonna calculate it. So n gonna divide it by v. But what about our final result? So I'm gonna prepare an empty string as our final result. So this means the result gonna plus equal to a string of this number v. Yeah, so v is just from 9 to 2. We're gonna check one by one. Yeah. Now what's gonna be the final result? So the final result gonna be result. I needed to reverse the result. So this is going to be the final result. Yeah, but this is not yet finished. So if we are lucky, so everything is okay, like 105. What about if we are unlucky, like we have a 44? So definitely we need to break the while loop. But how can we break the while loop? Even n cannot be equal to 1. Even n not equal to 1, we have to break it. Yeah, because for this example, if we get 11, how can we get 11? We cannot get 11 because 44 divided by 4, it is 11. And then for 11, we cannot find any numbers, but it is 11. So what should we do? So this means from here, we need a flag. So I'm gonna prepare a flag to maybe false. Yeah. So if I do any of the operations from 2 to 9 or 9 to 2, I'm gonna set this flag to true. This is very important to stop the while loop. Yeah. So from here, after the for loop, I need to check this flag. If it is still false, if not flag. So this means I can return a string of -1. Yeah. So from here, this means for this case, for the third example, definitely we're gonna find the -1 because 44 is not possible. The flag gonna always be false. There's no true. Otherwise, if we set it to true, it's okay. We will not execute here. We just return the final result. Yeah, I think that's all about it, but I'm not sure. Let's just run it. Yeah, as you can see, it works. And let me just submit it. As you can see, it passed for all testing cases, and it's pretty fast. So what about the idea? The idea is that we're going to use greedy. But sometimes if everything's okay, we're going to execute those kind of code. It is okay. Only if n equal to 1, we're going to stop it. This is for this testing case. And for 7, it's going to be this testing case from here. But what about 44? We're going to use this flag to check 44. Yeah, so this means everything going to be checked. And actually, those 3 examples are really good because definitely we found all the different cases. Now let's analyze a little bit about the time complexity. So for here, this is just a nonce array from 2 to 9. And from here, if n not equal to 1, and here for this for loop, so let's just say it is 10 because there are going to be 10 numbers. Basically, it's 2 to 9. It's going to be 9 numbers, but 2 to 9 is going to be 8 numbers, but it is okay. Let's just say it is 10. And now, if it is possible, we're going to make the number smaller and smaller. So what do we need? So basically, yeah, if we're going to use the modular, it's going to be log n time, and n going to be 10 to the power of 18. So log 10 to the power of 18 is going to be a really small number. That is why it works. I think that's all about it. Thanks for watching. See you next time.